is to determine whether Rolle's theorem can be applied to f of x equals x squared minus 3x on the closed interval 0, 3. The rules for Rolle's theorem is that f is continuous on the closed interval 0, 3, differentiable on the open interval 0, 3, and that f of 0 equals f of 3. Then there exists a c in the open interval 0, 3 such that f prime of c equals 0. First, we need to make sure that our first two rules are true, and they are because f of x equals x squared minus 3x is a polynomial. Next, we're going to assume that f of 0 equals 0 and that f of 3 equals 0. We then find the derivative of f of x, which is f prime of x equals 2x minus 3. We can then set this equal to 0 and find our x. So x equals 3 halves. Therefore, f prime of 3 halves equals 0. So c equals 3 halves, which is in the open interval 0, 3. Therefore, Rolle's theorem can be applied. Our problem is to determine whether the mean value theorem can be applied to f of x equals the square root of 2x minus 3 on the closed interval 2, 6. The rules for the mean value theorem are to let f be continuous on the closed interval 2, 6 and differentiable on the open interval 2, 6. Then there exists a c in the open interval 2, 6 such that the tangent line f prime of c equals the secant line f of 6 minus f of 2 over 6 minus 2. In this case, the square root of 2x minus 3 is continuous because for all values on this interval, f of x is greater than or equal to 0. The square root of 2x minus 3 is also differentiable because for all values on this interval, f prime of x is greater than 0. Now we need to find f prime of x. The square root of 2x minus 3 can also be written as 2x minus 3 to the 1/2. The derivative of that is 1/2 times 2x minus 3 to the negative 1/2 times the derivative of 2x minus 3, which is just 2. If we simplify this, it becomes 2 over 2 times the square root of 2x minus 3. The 2's cancel, and this becomes 1 over the square root of 2x minus 3. We then want to find our value of the secant line by plugging in our a and b. So for f of 6, we have the square root of 12 minus 3 minus the square root of 4 minus 3 over 6 minus 2, which is just 4. This then becomes the square root of 9 minus the square root of 1 over 4, which equals 3 minus 1 over 4, which is just 1/2. We then plug in our values for this equation. So we have 1 over the square root of 2x minus 3 equals 1/2. And because our numerators are equal, we can just cross multiply and we get 2 equals the square root 2x minus 3. If we square both sides, we get 4 equals 2x minus 3. Add 3 to both sides and we get 7 equals 2x, and x equals 7 halves. 7 halves is basically 3.5, which is on our interval 2, 6. Therefore, the mean value theorem can be applied.